Hello YouTube, this is Ravi. If you are taking signals and system classes, then you should have definitely heard about the famous convolution operations. This is one of the most confusing things for the beginners. When I was introduced to the convolution, the flipping up the signal and adding it up back didn't make any sense at all. But now I understand it, and convolution is something that appears in day-to-day life, and it is one of the most intuitive things, and I guess anyone can understand this. So I'll give you I'll show you the convolution in 3 steps, and you are able, if you haven't yet understood what convolution actually means, then this is the day you'll definitely understand it. And then after, I'll show you some other tricks, let me tell, other 2 methods to do the convolution operations. So let's start case 1. Let me change the color to the blue. So let's say you have a signal, you have a system, you have a system and you do not know what your system does. So what system actually does, it will take as the input signal, and it will do something with the input signal. So most of the times we do not know what our system does. So what we do is we send a delta impulse. We send the delta impulse to our signal, and we'll see, okay, what I'm getting as an output. So let us say our system is really simple. So let us say our system just multiplies everything with 5. So whatever signal you give, so if you give 1, then it will spit you out 5. So if you give your signal, okay, let's give 2, and it will say, okay, 2 times 5, it will be 10. If you give your system 7, then your system will say, okay, 5 times 7, it's easy, 35. So this is the first case. As soon as you give the input, you are getting the output. So let's go to a different scenario now. Let's go to case 2. This is one level up. That means our system is now a little bit different. So what our system basically does is, our system is giving not only one output, but it's rather giving a bunch of outputs. So this is the, so you, yeah, in the beginning you multiply your system with 1. What that basically means is, in signals and system, you are giving the delta impulse, because you're just giving a single impulse. So you see what will happen if you give the system's delta impulse. So for example, let us say, okay, your system will say you will get as output not only 1, but you get 4 outputs, also 4 signals in 1 0, let's say 3, let's take on another number 5. So when you are giving 1 as an input, you are getting 4 outputs. So at time 1 you are getting 1, at time 2 you are getting this one, and at time 3 you are getting this one, and at time 4 you are getting this one. So let's see what will happen. So if you are giving your signal, let's say you are giving your signal 3. So if you are giving your signal 3, then you'll get, okay, the system will say, okay, you are multiplying it with 3. It will give you 3 0, 3 times 3 would be 9, and 3 times 5 would be 15. Simple, right? Same way, if you give your signal, okay, if you say, okay, let's give 5, then your system will say, okay, that's easy. Then your system will just spit you out 5 0. 5 times 3 is 15. 5 times 5 would be 25. That's easy, right? But wait. Now we are going to case 3. So you have the system, and what actually happens is, when you are giving the input to the signal, you are basically giving the signal just one after another. Your system is yet not finished with giving the output, but you feed in the another input. So let me show you with the example here. So you have a system, you give the delta impulse, and you get, okay, let's take the same system. Your delta, also your impulse answered is, let us say 1035. So in the beginning, okay, let us take a signal. Let's take a signal 1 7 2 3. So this is your input signal. X k equals to, so at time t equals to 1, so you give this input. At time t equals 2, you give this input, and so on. So in the beginning, you are going to give the signal, give the system the input 1. I guess now you understand why we flip the signal, right? So because if you are giving this as an input, then this one is the first number that you give into the input. So when you give your signal system 1, then your system will say, okay, that's easy. I'll just write 1 0 3. I'll just multiply everything with 1. So here is the tricky part. So what is actually happening here is, this is, let us say this is time equals to 1 second, this is 2 seconds, this is 3 seconds, and this is the 4th second. Your system is not yet finished, but you are now feeding your system with another output, also another input. You are now telling your system, okay, now you get it, now you get the 7. So now what your system will do is, your system will multiply the 7 with all the numbers here. But it will be 1 second later, because you are feeding the signal at the time t equals to 2, not time t equals to 1, but rather you are feeding the signal to the time t equals to 2. So what it will do is, you'll have, yeah, 7 times 1 would be 7, 7 times 0 would be 0, 7 times 3 would be 21, and 7 times 5 would be 35. So, and now let's go one step further. At time t equals to 3, let me choose the same color. At times t equals to 3, your system is yet not finished. Even your first input signal is not finished, even your second input signal is not finished, but you are actually feeding your system the next input signal. You're feeding now 2 to the system. You keep the 2 as an input, your system will say, yeah, that's easy, I'll just multiply everything with 2. But you start at time t equals to 3, because we are feeding the system the signal 3 seconds later. So what you will do is, you will multiply everything with 3. So it will be 2 times 1 equals to, 2 times 1 equals 2. 2 times 7 would be 2 times 2 times 0 would be 0. 2 times 3 would be 6, or 2 times 5 would be 10. In the similar manner, at t equals to 4, you you give the input 3 into the signal, 3 into the system, and your system will do the same thing again. So you start a little later, and it will multiply everything with 3. So 3 times 1 is 3, 3 times 0 is 0, 3 times 3 is 9, and 3 times 5 is 15. So in this side we have our time axis. Let me extend it. Here is our 4, 5, 6, 7. So we have now 7 seconds, and you basically add this up like this, in this manner. So at time 15 seconds, you'll get 15, 19 here, and 36 plus 5, it would be 41. 21 plus 5 would be 26, plus 3 it would be 29, 5, 7, and 1. So this is your output signal. I hope you got the idea what it is actually doing. It's just adding up the signal, but your system is yet not finished, so it will just add up together with the previous input. That's the basic idea behind the convolution operation. So this is the most intuitive approach to understand this system, understand these convolution operations. So let me show you two other tricks to solve these problems. So one of the method that I like is this one. For example, you write your signal like this: 1 7 2 3. This is your input signal. You make a dot in the between, and then after you write your impulse response, let me say in English: 1 0 3 5. So you multiply this one with all the things here, one time with this one, this one, this one, and this one. So when you multiply one with everything here above, it will be 1 7 2 3. Now you multiply 0 with all the things here, so it would be, yeah, it would be bunch of zeros, but 1 second later, because we are delayed by 1 second, so it will be 4 times 0. Then you multiply with 3 just a second later. 3 times 1 is 3, 3 times 7 is 21, 3 times 2 is 6, and 3 times 3 would be 9. And you do the same thing with 5 just 1 second later. So 5 7 to 35, 5 to 10, and 5 times 3 is 15. So here you have that, and now you add it up. So you are getting your output as 1 7, 2 plus 3 would be 5, and here is 29, 41, and 19, and 15. You see, we are getting the same thing as an output. It should be same because basically it's the same operation. So let me show you another method to do this convolution operation. This is the most famous, and I guess this is the most easiest way to do convolution when you are asked in an exam, or when you have to complete it in a really short amount of time. So we'll write our impulse response here in this axis, and we'll write our input in this axis. So let us write here 1 0 3 5, and this side we'll write 1 7 2 3. Now you multiply everything here with 1 times 1 is 1, 1 times 0 is 0, 1 times 3 is 3, 1 times 5 is 5. So we do the same thing with the 7 0, 7 times 3 is 21, 7 times 5 is 35. You do the same process, you repeat the same process with 2. It's 2 0, 2 times 3 is 6, 2 times 5 is 10. Now 3 3 0, 3 times 3 is 9, and 3 times 5 is 15. So after you have done that, you add it up in the diagonal, in anti-diagonal axis. So you basically add it up like this manner, each way. Now let's see what we get. So our output will be the sum in this axis. So 1 in this axis, hence the color in this axis. So it will be 1 at the beginning. 7 plus 0 is 7. 2 plus 3 plus 3 plus 3, sorry, 2 plus 0 plus 3 is 5. And then after, yeah, 29, 41, 19, and 15 manner. Right, you got the idea. I guess you got the idea. So the most intuitive part is here. This should be the most intuitive way to understand the systems and signals, the convolution operations basically. I have written this the same input signal in MATLAB. Let me try to show you here. So this is something that that's my own function, and this is the built-in MATLAB function. So I have the same input signal x and same impulse response x here. So when I run it, we go, bring it back here. Okay, let's see what's our output signal. So here we go. So 1, you see here, 7, it's somewhere here in between. 7, 5, 29, 41, 19, and 15. So that's how we do convolution operations. So if you understand the video, please please give a thumbs up. YouTube algorithm will recommend it to more people. And yeah, if you want some similar contents like this, then stay tuned. Hit a subscribe button to my channel, and next video I'll be showing you how to do these operations in MATLAB. Peace.